Good evening, everybody. My name is Casey Ball, and here is my presentation on the military geography classes population and resource exercise. So, what we need to talk about first is that some of the estimates of the world's readily accessible and very easily extractable hydrocarbons and fuel resources are starting to get harder to get to, and maybe some of our reserves and things like that have been overstated, excuse me. But we have some alternatives that are on the rise right now. For instance, let's start with Canada and the Athabasca Tar Sands. So, as part of this is population exercise, let's talk about doubling rate of Canada's population, which is 83.3 years. Now, we're also looking at Michael Klare's book, The Race for What's Left, and this is about the race for resources. So this chapter didn't have too much to do with populations really, or overcrowding or anything like that. But let's look at some other ones. So 83.3 repeating years for Canada, which can be economically punishing because it's not a very quick growth rate. Canada's always been quite underpopulated. It's, I think, only 4 people per square kilometer, which is an extremely low population density in the first place. And I think about 90% of their population lives within about 150 miles of the US border. So make of that what you will. But the Athabasca Tar Sands are large bitumen deposit span that are in northern and central Alberta, Canada, province of Alberta. So normally bitumen is soft and tarry, but it works and can be refined as a sort of petroleum replacement. But this far north, it's frozen solid, and sometimes it needs to be superheated and melted and turned into something called syncrude, but more often than not, it is an ore that's excavated and refined out of the sands. So what they do is traditional strip mining operations, and these have gone really, really far. There's, huge things like bagger excavators that are the size of buildings, size of hotels. And so what they do is they strip mine tons and tons of just the ore, the sand, right out of the top of the soil, just right there. And they ship it on to a refinery that's also in Canada usually, or sometimes to Illinois and Texas in the US. And that plays into the Keystone XL pipeline that has been sort of a big talking point in American politics for the last couple of years. But it was something Trump was really behind, and Biden has since put a nail in the coffin of that. So what we've got is we figured out about bitumen and the tar sands back in the 70s during the OPEC crisis, when people really started to look at, there's 2 OPEC crises, but we started to realize we needed to look at some kind of alternative or something like that. It was shelved once that ended, and then back in the 90s, people started to actually figure it out. The problem with it, and with all these other resource extractions, is it costs too much energy, too many resources, and it's too ecologically damaging to really be feasible. So what happens is this ore is taken to a refinery and it's treated with water that has sand, silt, and chemical solvents in it to help break down all the actual other things they don't want, like silica and just regular sand, and just get the bitumen out of there. So Mario Reynolds of the Pembina Institute, which is an ecological watchdog in Canada, says it's like using caviar to make fake crab meat. And that's something you'll see in the rest of these. But they have potentially an extra 1.7 trillion barrels of oil. Everybody's scrambling to find the next oil. And that goes between IOCs, international oil companies, and NOCs, national oil companies. And a good example of one of those is Venezuela. So Venezuela's population doubling rate is 35.71 years. That's pretty decent, actually. If they were too much quicker, it'd be a population time bomb, but it seems to mean good things for them, although they've been experiencing things like hyperinflation and high levels of instability. But what they already make a lot of petroleum. They already produce a lot of crude, barrels of crude. There's heavy and extra heavy oil, which we've not used before, but there are large deposits of this in the Orinoco Belt, which is around the Orinoco River. So possibly another 1 trillion barrels of crude that could be added to the global supply. It's dense, it's thick, it's nasty, but it's very viscous, and it doesn't really travel up oil pipes. It's also a bitumen product, like in Canada. So this is something that people in China and India are also looking at. And let's talk about those doubling rates. China's is 241.37 years, which is very, very slow. Could be bad in the coming future, but they have such a huge population as is. And then also India, which is 73.68 years. Now, these are the two most populous nations on Earth, but they have a vast difference in their reproductive rate. So that depends on how many people are going to enter the workforce and how many people are going to use oil. In any case, we have the national oil company started by Hugo Chavez, who nationalized all of the oil in Venezuela. And that kind of drove out all the IOCs, but then he realized he had shot himself in the foot. He didn't have the brain power and the technology of the IOCs and started to court them back. Chevron came back. But yeah, the problem with those is they need to be superheated or they also need to be treated. And it's just hard to get them out. It costs more energy to get them out than regular petroleum already does, which takes a fair bit. So we have this continuing problem of the technology isn't there to get these new resources out. So then let's move on to U.S. shale oil and gas and fracking. That's a big hot button topic right now. So the U.S.'s population doubling is 122.8 years. It's very slow. And we're the third most populous nation on Earth, but we're well behind pretty overcrowded places like China and India. So that could be very bad for us in the future. So we have potentially another 2.8 trillion barrels of oil, of crude, in the Paysense Basin, which covers Colorado and Utah. So this is formed from residue of ancient swamps and lake bottoms that are only about 1,000 to 2,000 feet below the surface. And when we heat up this residue, it's turned into something called kerogen. So we have to heat it up to between 530 and 930 degrees Fahrenheit to liquefy and be able to pump it out of the earth. So lots of IOCs started to look at buying parcels of federal land and or just free lands that hadn't been owned. Bush approved a lot of this and for fracking, the start of fracking. Obama kind of tried to curtail it. Trump really bought into it, and Biden seems to be pushing back against it, especially with the Keystone XL, as I mentioned. So we've got hydrofracking, which is more of a method of getting gas back out, natural gas. And we have about 600 trillion square feet of natural gas that's untapped. But Poland and France are also looking into this too. We have a lot of problems like flowback and radioactivity because all the things we use to treat water, we use this high pressure water. We have to horizontally drill around inside the shale, which is really tight formations of rock. And it causes a lot of problems. We've seen a lot of boom towns and things like that in North Dakota and Montana, where most of the gas is, and they're kind of hellish. And so are the Athabasca Tar Sands. They're a blackened moonscape, but there's really bad conditions over at those boom towns, especially with water, and it's poisoning a lot of aquifers and rivers and things like that in the US as a byproduct. We've also got something called coal bed methane in the US coming out. We've got tons and tons of coal reserves in the US underground, and we used to dig a lot of it in West Virginia. And we would try to avoid methane because it could cause an explosion and cave in everything. But now we're figuring out there's a way to liquefy methane and bring it to the surface, but it's also costly and resource intensive. Another country that's looking at this is Japan. Japan is really interested in methane crystals, which are these ice methane crystals that they're trying to figure out. Now they have potentially 100-year supply. They're not really looking at exporting it. They have a national oil, gas, and metal corporation, JOGMEC, and their population doubling rate is infinite. Who knows if they'll really have that many people in 100 years to even use it. But that's the continual problem, is this is too much to be able to use. It's sort of unsustainable until we figure out a better technology. So thank you so much for listening to me talk about this review of this chapter. Good luck on the final.